Greetings and welcome to the United States Transhumanist Party Virtual Enlightenment Salon. My name is Gennady Stoliarov II, and I am the chairman of the U.S. Transhumanist Party. Here we hold conversations with some of the world's leading thinkers in longevity, science, technology, philosophy, and politics. Like the philosophers of the Age of Enlightenment, we aim to connect every field of human endeavor and arrive at new insights to achieve longer lives, greater rationality, and the progress of our civilization. Greetings, ladies and gentlemen, and welcome to our U.S. Transhumanist Party Virtual Enlightenment Salon of Sunday, September 29th, 2024. Today we have a fascinating conversation in store for you about mathematics and cryptocurrencies, in particular the most famous and original cryptocurrency, which is Bitcoin. Today, we are joined by a panel of U.S. Transhumanist Party officers and members, including our Director of Visual Art, Art Ramon Garcia, our 2024 U.S. Vice Presidential Candidate and Director of Community and Citizen Science, Daniel Tweed, our member from Texas, Alan Crowley, a frequent Virtual Enlightenment Salon guest, and our special guest for today is Dr. Giovanni Santostasi. He is a man of many talents. He has a Ph.D. He is considered a modern Renaissance man, as he views his native Italy's Renaissance movement as a historical precedent of transhumanism, which it certainly is. He received his Ph.D. in physics, working on gravitational waves and neutron star astrophysics, and he has spent over 20 years analyzing complex data in several scientific fields. He is also a neuroscientist and the Neuroscience Advisor for the U.S. Transhumanist Party. Furthermore, he is a financial analyst and currently is the CEO and Director of Research at Quantonomy. He is the author of almost 100 research papers, and his works have been featured in prestigious scientific journals, as well as receiving attention from popular media like Men's Health Magazine and ScienceDaily.com. But today he will be talking about an idea that has been based on his research on the price movements of Bitcoin, which is the theory that Bitcoin's price follows a power law. So welcome, Giovanni. We are pleased to have you on our Virtual Enlightenment Salon, and we've got your presentation pulled up here. Please feel free to proceed.
Thank you so much. It was a fantastic introduction. Thank you. Very well done and complete. I'm very happy to be here. I noticed, by the way, that beards are a pattern. Maybe it's me looking for patterns everywhere, but I see some consistency here. Anyway, I wanted to discuss this topic with you because I'm doing this work since about 12 years. I've analyzed Bitcoin data for almost 12 years now. I actually heard about Bitcoin. I think I heard about Bitcoin in 2010 for the first time. I downloaded the wallet, and then I didn't do very much with it because at that time the instructions were mostly for hackers and for people like Hal Finney. That, by the way, you probably recognize the name because actually he was one of us, right? Directly or indirectly, he was somebody very much interested in the things that we find interesting. Maybe even Satoshi, but I didn't do anything with that wallet because I said, okay, I'm going to study how it works. This mining idea, it sounded really cool, but I put it in the back burner. But with Bitcoin, I think it's always a bad idea. And then 2 years later, in 2012, I actually read. I think it was for an article in the Institute of Emerging Technologies. And so that is actually a very important link to me with other transhumanists. An article where maybe you guys remember the author. I was trying to pull it up. I had it actually pinned in my X account, but then I unpin it and I cannot find it. But it was an article where another transhumanist it was making the case that basically his argument went like this. He was saying, many of us want to change, many transhumanists want to change the world. We want to do all these amazing things, cure aging and cancer and send people to Mars, integrate with AI and all these kind of things. But many of us don't have the resources to do that, right? Maybe we are successful professionals in our field, but we don't have the hundreds of millions of dollars that will be necessary to do this kind of project. And then they introduce Bitcoin and say, but look, there is this thing that will allow us, if it goes where it's supposed to go, to actually do that, because it's early. At that time, Bitcoin was about $9. And if you invest right now, and the coin goes where it's supposed to go, maybe to hundreds of thousands or even million, you will be able to do the things that you would like to do. So I was very impressed by that. And by the way, at the end of the article, there was also a little chart of Bitcoin. And we'll tell you a moment about the chart. But yeah, so that was amazing because, and also given this person, I don't remember his name, maybe I can find it later, Gennady, and I can give it to you and you can link it to the comments of this video. Was a very nice, well-written article and very visionary, right? Actually, it's a testament to our ability as a transhumanist to see future patterns, because many people thought of it, this was nothing, was a toy, was a meme, was a joke, but this person took it really, really, really seriously. He was describing the technology, its main features, and he was able to see that eventually he will become very successful also financially, but he will be taken seriously by the rest of the world. And I think only transhumanists can do that. We are equipped with our visionary nature, with our ability to see the future in a very positive fashion. And you can see how being a transhumanist actually can help you with things like that, because if you invested in Bitcoin early because actually you read the transhumanist article, you will be okay today. And so I'm very, very grateful. And to me, the connection is very natural. And I want to hear from you guys if you think the same, that there is a connection there between transhumanist ideas and Bitcoin, right? Even this idea of decentralization. We could talk more about the philosophy behind it. But I also want to share with you the things I found, because I think actually allow us to see the philosophical aspects too. And I was mentioning the chart. So in the end of the article, we had this chart. It was like silly because markets started to open around the end of 2010, and this was 2012. So there was no much data, and this guy wanted to actually try to see a mathematical pattern again. Like we are people that like science, math, data, and so he was trying to describe the data. He arrived to the conclusion. He had the two main statements. One, at that time we had a huge big bubble for the time that went all the way to something like $30. Then it crashed, and many people were talking about tulips. And I don't hear much that going on today, but we were saying tulips, 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 because we were making the analogy, with the famous event where the people in the Netherlands speculated on tulips and then realized we can get as many, we can, like printing money, we can print tulips as many as we want, because it's relatively easy to replicate them, and the market crashed, right? And a lot of people got hurt. And so people were making this analogy with Bitcoin, but in the article we were saying no, because bubbles don't recover like this, because we had enough data to see after the bubble that actually Bitcoin recover. And if you forget the bubble, and you could, with your eyes, you could see the bubble was, you can almost cancel the bubble because it went up and then went back kind of to the general trajectory, it looks like exponential. This is what he said. But it turns out Bitcoin is not exponential. I make a big deal out of it. It's actually a power law. And this is what I'm going to tell you about. And power laws, probably you guys are aware of it, are very, very fascinating type of mathematical pattern, because a lot of phenomena in nature follow power law. In fact, they are almost like an internal joke. One time I saw, I didn't make the shirt, but I saw a shirt online where somebody wrote, I went to a physics conference and all what I got was a lousy power law. All what I got was a lousy power law, because we are a little bit too enamored with them, where we see them everywhere. They are everywhere, but the motion of the planets is a power law. There are beautiful relationships between the metabolism of an animal, for example, and the mass of an animal. That is a power law, famous power law called the Kleber's law, and many other patterns. What I was missing personally was because of course, as a physicist, I work with power law. I found many power law. I had to study many power law in astrophysics. Galaxies have power laws. They are everywhere. Many natural phenomena. Was the social connection. I didn't realize that actually physicists started to study. Well, they started to move first in biology, and they started to find a lot of this pattern. And many biologists resisted because they didn't want this more mathematical approach to their science. And then actually they started to move into social phenomena, in particular studying how cities grow. And a lot of the patterns that you observe in the growth of cities, not just the city itself, but also things like gas stations in a city, they follow power laws. And so it's very interesting, because even from a transhumanist point of view, because, for example, this idea that we can understand human history or destiny through the development of technologies, for example, and the fact that technology follows very precise pattern, basically what Ray does, right? Ray Kurzweil does. That was actually an inspiration for me. So when I combine, I was already, in fact, at that time was also my discovery of transhumanism around 2010, 2011, when I met first Ray and then Aubrey. It was like a renaissance for me. My world opened, and I couldn't come back anymore. And so when I put it together, I saw actually, I don't know if you guys are familiar with this scientist is called Jeffrey West. He wrote a book called Scale that I really recommend. Maybe we can put it in a reading list if you don't mind, Gennady. I really recommend this book. And the book is called Scale because the main property of these power laws is scale invariance, right? They behave at the same level, in the same way, at different scales. And so he wrote an entire book called Scale to describe how important it is, the idea of scaling, how it impacts everything around us, and that we can understand the world differently if we learn about this concept of scale. And Bitcoin, it's a scale invariant system, if my research is correct, and I want to share that with you. So I'm going to take a pause and see what you guys think, if you have any questions, or if you want to interact with me, and then I can go and show you more of my, show you my work, what I found, and why I think is relevant.
Yes, thank you very much, Giovanni. And here is the link to the book by Jeffrey West entitled Scale, the Universal Laws of Growth, Innovation, Sustainability, and the Pace of Life in Organisms, Cities, Economies, and Companies. So please check that out on Amazon. And furthermore, for those who would like to read Giovanni's article, The Bitcoin Power Law Theory, here it is on Medium. But in terms of the power law itself, and perhaps your slides will go into this, but some of our viewers are wondering essentially mathematically what is a power law. Now, I know what it is, but I think it would be useful for you to explain essentially the mathematical form that a power law takes and what kinds of phenomena in the world have been observed to follow power laws.
Okay. Yes, and maybe we can go through my slide because I will cover the topic. So, all right. So for some reason I hear you in the background. I don't know, or maybe because I'm running. Okay, let me turn off this. I was running also the video in another window. I have too many windows open. But anyway, so my entire goal. So yeah, maybe let me actually start from the previous slide because it's the title of the presentation, and there is a meaning in this. And this is why I also think it's relevant for transhumanism, because if this angle that the author of that article that I mentioned, that he was a transhumanist, the one that we use this term in this Bitcoin world, that we say orange peeling, when somebody convince another, through, it's not just one thing, but sometimes there is that little critical push that you need. And when we do that with other people, we call that process orange peeling, right? Like in the Matrix, where you have to choose the two peels. This one is a third alternative where you can take the orange peel and get out of the Matrix anyway. So that is how Bitcoiner think, meme related to. And so that the idea of orange peeling, that through that article, that was a transhumanist, that was orange peeled by another transhumanist. And the main thing that article was conveyed to me was, I was mentioning the money, but the money is just a mean, because in fact he was trying to say how, we need the money to do this, right? To not to go and buy a big yacht and having girls dancing for us, but actually to do things for humanity. So to me, the search for human value, to what we consider value and what is important to us, I think is a very important topic related to Bitcoin. And I mentioned the other things because, as you will see in my presentation, all these important fundamental quantities like energy, time, they are all involved in this understanding of Bitcoin based on if it is a power law. It gives us a different side. They are all linked together, and Bitcoin represents kind of a universe where all these things somehow are interconnected with each other. And so my approach, being a scientist, when in particular, when I saw this presentation, I saw the chart, I immediately actually went and got the data. That was also very fascinating to me, that this asset had all this data, what we call the on-chain data, where everything is recorded. We have all the price, we have how much computational power is needed to run the system. We have a measure of the activity in this system. I'm doing a little spoiler. It's a network, so it's the addresses, for example, represent some kind of a proxy for the activity in the network. So I was very fascinated by all that. I downloaded the data, and being a data fanatic, is what I do from morning to evening, plotting chart, trying to understand patterns. I started to find this pattern. In fact, once I saw a lecture, a TED lecture by West, and he was talking about cities being like this pulsating living organism, with the road being like the kind of the circulatory system of the organism, the communication connections being the nervous system. And so it really talked to me, because it seemed like poetry. He's very eloquent. If you have a chance, please watch some of his talks. He has a Google talk, a TED talk, several. And I almost immediately saw, also because, all the background that I already had, it really, I'm very thankful to my transhumanism understanding and worldview, because I immediately saw Bitcoin being that city is just in the digital world. And they say, oh, Bitcoin has to be like that. And they started to go and look for the data, and I immediately found these patterns, right? This was around 2013. I started to find power laws. I found power laws between the price and the addresses. I found a power law between price and transactions. It was amazing. And it was really cool that I was right, that this intuition was right. And I was part of this very large group where several transhumanists were there, actually. It was called Bitcoin and the Internet of Money. So before X, it was one of the places where people could go and talk about Bitcoin, and it added, more technological angle. We had at a certain point, we had almost 70,000 people in that group. Alex Lightman was one of the moderators in the group. David Orban was, in fact, I think Alex created the group. And David Orban was a moderator. I was a moderator. So we had a very, very different angle in looking at Bitcoin, very transhumanist angle. So this is the first graph I always show, because this graph is what most people see when they hear about Bitcoin on a TV program, like on the news or CNBC, etc. They always show a linear graph. So basically, we are seeing the x-axis as linear, the y-axis as linear, and the days here are represent. Usually, we have dates, but they represented the number of days since the creation of Bitcoin, because this is my time measure. The time measure that I'm using is almost like I'm taking the creation of Bitcoin. It was January 3, 2009. It's also called the Genesis block, as my starting point. It's my Big Bang. The entire Bitcoin universe was created at that day. And so these days that you're seeing here are days since the Genesis block. And when you see a chart like this, you don't recognize any pattern. It looks very disorganized. Like, well, maybe in general it's going up, but there are these huge jumps in price, and then the price comes down, crashing, and that is very scary for many investors, because they think, I will never put my retirement on something like this. It's absurd, because it's going up, but who tells me that one of these days goes down all the way to zero, right? So it's very likely this enormous swing. So it doesn't look there is a pattern there. So as a physicist, we are trained when we look at data, because that is where we start. We all collect data about the universe, different phenomena that we want to study, and then we are trying to see if there is some kind of regularity, if there is some kind of a pattern, and then we use, like my ancestor Galileo said, the language of nature, that is mathematics, right? Galileo say nature is a book and is written in the language of mathematics. So use mathematics to make sense of these patterns and try to find maybe ideally that the Holy Grail, maybe an equation. It is kind of crazy to think that there is one single equation that can describe the behavior of something complex like Bitcoin, right? A financial asset that is bought, sold, on the market on 24/7. It's kind of a very crazy idea to think that actually you can do that. But when one of the tools that they teach us as a physicist, and for a moment forget this rainbow kind of colorful display, let's focus on the black curve. When we want to go deeper in the data, we don't give up at this first level, that is a linear graph. Now, many phenomena, even in the linear graph, they look kind of like a line, right? Maybe a fuzzy line if we're dealing with a lot of noisy data. It will look like a fuzzy line. But, in general, you can see there is some kind of correlation, like a linear relationship between the two quantities. In this case, we are studying price and time, but it could be anything that, let's say, a physicist see, because I'm going to describe things like a physicist will see them. And in this case, what we don't find this linear relationship. There are many linear relationships in nature. Usually, when you look at small changes between two quantities, they can look linear, at least in that little range. But the thing with Bitcoin is that we are not looking for small little changes locally where things could look linear. We are looking for enormous changes because, it depends when you did this research, but in particular, if you do it now, we went from fraction of a dollar. In fact, if you go to there are few recorded transactions that happen before the first exchange is open, because most of my chart use exchange data. So they start at 2010 when Bitcoin was created, 2009, because they are more reliable data, right? We have 24/7 data. They are recorded. Everybody agrees on them and so on. Before the exchanges, transactions were more peer-to-peer. It was more, there was not consistent record of them, so I don't use them. But I did some exercise where retroactively I went back and I introduced some of the early transactions. In fact, the first early transaction that we know of was $1. Imagine that, right? $1 for 5,000 Bitcoin. In fact, I always joke and they say, if I really had to use my physics skill, forget about charting, invent a time machine so we can go back and buy a bunch of Bitcoin when it was so cheap, then we can fund any transhumanist project that we want. I don't know. I'm working on it. I will let you know, guys, when that happens. So I will give you a ride. But right now, this is all what we have to do, to use physics to try to see if we find patterns and predict the future. But in this chart, what I do, when you have a phenomena that spans many, many orders of magnitude, what you want to do is to take the log. So I'm taking the log of a y-axis, and the log allow us to focus, to change the focus. I say all the time, it's almost like we are taking a drone. We don't see the trees anymore. We don't want to focus on the tree of the forest. We want to focus on the forest, on the shape of the forest, how big the forest, because we want to see if there is a general pattern there that we maybe are missing by focusing on the tree. So the linear chart is more like you are focusing on the single event, this huge big jump, these bubbles that we observe seem to dominate the data. And when we take the drone, you see how the bubbles are much more controlled, right? They are much smaller, and they are also proportional, because in the linear graph, when we look at the linear graph, the early data is so small in comparison, because we are talking about fractions of dollars, $10, in comparison with things like $60,000. So it looks flat, and the bubbles don't seem proportional, right? When you take the log, they do. And also, you start to see there is a much more organized pattern. A trained eye will almost think that through that data, there is actually maybe a precise mathematical pattern, but it needs to be verified. The problem with verifying it is that our eyes are much better in looking for straight lines than something that is curved. Now, there are sophisticated tools that we can use to find if there is a curve there that is not a straight line, but it's much more difficult, even from an intuitive point of view, to recognize a pattern if it's not a straight line. Straight line, everybody likes straight line. We recognize straight line. And by the way, so two things. First of all, I know that most of our audience is technical, so probably everybody knows what a log is, but let me, if you don't mind, Janet, I will give a little explanation of what the log, or at least a reminder of what the log does. The log, so in science, we like to represent, in particular when discuss things that change a lot, right? They change what we call orders of magnitude. So orders of magnitude are things like 10, 100, 1,000, 10,000, right? And for example, in my field, my old field of astrophysics, that is very common because we talk about, huge, big objects, we go from planets to galaxies, etc. So these orders of magnitude are very common when we discuss things. These order of magnitudes are also called scale. This is why that book is called Scale. So you are focusing on the scale. You want to see if now I'm describing things in terms of scale, things look better. Now I can find a pattern in terms of a scale. And the log is perfect for that, because when we look at scale, often we use this, what is called a scientific notation, where we write a number as 10, 10 to the 2, 10 to the 3, 10 to the 4. So basically the number of zeros in the number. And that little exponent, it's also the scale of a number. And if you take the log basically is the operation. Almost think about like a little box where you put in something and it spits out something else. You put in the number and it spits out the exponent. So in this case, if I put in 10, it gives me the exponent 1. If I put 100, it gives me the exponent 2. If I put 1,000, it gives me the exponent 3, and so on. So you recognize these numbers now as $10, $100, $1,000, $10,000, and 0 is $1. Minus 1 will mean 1/10 of a dollar, and so on. But you see now, by focusing on the scale, we see this very nice organized pattern. It's not enough because we don't see a straight line. This graph, we do always as a first step in analyzing data. It's basically like a sequence. You start with a linear, then if you don't see a straight line, they teach us, like in our lab classes, try to take an exponential, try to take the log of a y-axis and see. Because if you see a straight line in this type of graph, then you're dealing with an exponential. That is what happened, because the log basically cancels the exponential. So you're going to see a straight line pattern. And you can see here, I plotted the Bitcoin trajectory versus a straight line. And they are not the same, right? It's obvious that it's not the same, because if Bitcoin was an exponential, it will look much more like a straight line. Everybody agrees on that? Do you have a... and because that is what actually in that paper we're claiming it's an exponential. Maybe early on it was confusing, right? If you have a little bit of data, you could confuse and think you're dealing with an exponential. This is something that I'm dealing, I have 38,000 people following me on Twitter, and I struggle with this all the time, because a lot of Bitcoiners want to believe the myth and the legend that Bitcoin is an exponential, and it's not. The data clearly shows it is not. And there are, people will think that an exponential is good, right? Because we go up fast and we became all millionaires, etc. But actually, I will show you, as we discuss, that exponential is not good for something like Bitcoin. If you had to choose a pattern, it's a power law, and we will discuss why. And the next trick that we can call it trick, but it's more like an analogy will be as almost like a mathematical telescope or microscope, right? It allows you to see things that you will not be able to see if you use other tools. You're not manipulating the data. You're not changing it. You're not doing anything. You're just displaying it in a certain way. So if you now take the log of the x-axis, and we do that all the time because a lot of mathematical, physical laws are expressed in this way, in this power law that I will explain in a moment, the mathematical form of a power law, and then telling you how you find these power laws in the work of a physicist. The third step, and I don't know why it took me all this time, because I discovered this in 2018. So while my first power laws in Bitcoin go all the way to 2013, when I found the power law between price and addresses, price and transaction, I always did a second step that was, okay, if there is a relationship between price and addresses, then how addresses and addresses represent some kind of adoption, because we are representing the activity in the network, the nodes in the network, how this adoption grows. And being a technologist, being somebody that was familiar with Kurzweil work, I thought, well, it will go up like an S-curve, right? Because that is the famous S-curve of adoption. It is basically the integral, is the cumulative sum of a distribution of a bell curve, right? And so, there are some early adopters like Transhumanist Party, of technologies. Then there is the average person. Then there are the people that, the Luddite, that take a long time to adopt the technology. So usually adoption in technology, it looks like an S-curve. And it doesn't work for Bitcoin like that. And in fact, actually, I will show you what Bitcoin follows in terms of adoption. But when I was trying to apply that kind of model, I will always get some weird results. So finally, out of, I don't know, desperation or curiosity, whatever, I decided to say, why don't I do a log plot of price versus time directly? And I saw this, okay? And as a physicist, because I play with data all my life, for many, many years, I look at astrophysics data, I look at neuroscience, because at a certain point, I had a pivot in my life and I started to study the neuroscience of sleep. So I look at all kind of data. Rarely you see data that looks so straight. I know for the untrained eye, maybe not, because you see still the bubbles, you still these oscillations, so it doesn't literally look like a straight line. But you will agree, right? I want to see what you guys think, that the data seems much more linearized, right? It looks like now, yes, there is a pattern. There is a very clear pattern, right? What you guys think about this transformation? I was shocked when I saw it for the first time. Does it look like something weird is happening here, right, with the data?
It looks like it oscillates periodically around the diagonal line, though it does seem like the oscillations are becoming more frequent over time.
Actually, that is an artifact of a chart because we are taking the log of time. So they actually periodic. Thank you for the observation; it's very good. But it takes some training in looking at these log plots to understand this plot. The first bubble, it's actually an anomaly, so it doesn't follow a precise pattern. But the other one are periodic with a 4 years period, and they look more frequent simply because it's an artifact of a chart. Like, for example, it's an artifact of a chart where these things looks curved like this when actually it looks curved like that in a linear graph. So you have to be a little bit trained or be familiar with these kind of transformations to understand all the details. But that is what it seems. But actually, it's because of the time that we are taking being log times, and this is what you see in the x-axis. These are the log 10 of the days from the Genesis block. So when you see 3 means 1,000 days, for example. When you see 4, it's 10,000 days, and so on. So actually, they are periodic. They look more compact because of the nature of a log. And by the way, I draw in blue the time where it was discovered in 2018 up to now. So that is the blue, basically what we call out of sample data. So it's basically since it was discovered, the prediction of this model was correct all these years, like basically 6 years. The reason now, because the power law became famous this year. Everybody's talking. I got interviewed maybe 40 times by different podcasters. It's really popular. Many people resist it for different mental ideas, mental, let's say, worldviews or whatever. But it became famous because I posted 6 years ago. Imagine that blue data is not there, and then this was on Reddit. I did a stupid mistake of not writing a scientific paper. By the way, I am in the process of doing that, like a peer review paper on all these discoveries. I posted in the famous scientific journal called Reddit, that probably everybody is familiar with. And people, I had some good comments, but a lot of people were telling me I was crazy. I didn't know what I was doing. And then 5 years later, I posted again. And the first Reddit post was called 10 years of power law behavior in Bitcoin. And the second one was 15 years, so now I had some evidence to show that I was right. And that post really went crazy. And one of the people over Reddit is this young YouTuber called Andrei Jik. I don't know if you generally call it. I know him. He's a Russian also. He's very popular with, so in particular with the young people, because he gives financial advice, etc. And he likes Bitcoin. And he wanted to have an interview with me. And I didn't know who the guy was. We had the interview, then I show the video to my son. He's a video maker. My son went to school, master degree and that. And he saw the video and said, you know who this guy is, Giovanni? I said, no, I don't know who is this guy. It's like he's like one of the top 3 YouTubers in finance, like you will get a lot of attention. This is why this argument exploded this year. But we have 6 years of out of sample data. So your observation that the data oscillates is very good, because that is exactly what it does. The red line that I draw here is what is called a regression. So you take the logs and it looks like a straight line. That is exactly a technique, a procedure that we physicists follow all the time when we suspect the presence of a power law, because the data looks linearized. Like here, it could look very fuzzy, maybe dots all over the place. Here it looks like there are these oscillations that is unique. I didn't see many systems like this that are power laws and they also have oscillations. You calculate what is called a regression. So basically you say, look, yes, there is ups and downs, there is fuzziness, but in general, it looks like a straight line. So draw me the straight line, the best fitting line. And that's an algorithm that basically tries to find the best line that minimizes the distance of all these dots. And when you look at that, it looks like the dots are equally distributed above and below the red line, right? This is how it looks like. And in fact, if it was not the case, then when we do all the stats that I will discuss in a moment, the answer will be no, it doesn't look good, because the bubbles dominate. It needs to be like that, distributed above and below, to actually for the line to be a good representation. In a sense, all the noise, if you want to think of this deviation from the trend being noise, cancel each other. The data above the power law are canceling the data below. And in a moment, we will see that is exactly the case. Now, the beauty of drawing this line, first of all, our eyes is agreeing. Yeah, look, it looks like a straight line. Yes, crazy. And the second one is that it gives us important information. So we can extract from the line the main characteristics that are the slope and the y-intercept. And both of them have meaning. The most important meaning, it's actually the slope, because the slope, I don't go in the details unless somebody is asking, then I can show you why. But you can write an equation derived from the parameter from the curve. The main parameter, like I say, is the slope. The slope turns out to be the exponent of the equation. So basically, if you have a power law and the stats says you are dealing with a power law, and by the way, let's talk about the stats. The stats, there are many stats that you can do. One of the simplest one is what is called the R square. So the R square tells you how good of a fit you're dealing with. And in this case, that number can be anything between 0 and 1. If it is 1, it will mean, you will see the black dots basically on top of a red line. In this case, we get 0.95. The interpretation, it's a simplistic interpretation, but at least gives us a feeling, is that 95% of the data is described by that damn straight line. It's so simple, so incredible. Like what simpler than a pattern you can have in a straight line? But that straight line does such a good job in describing the data that basically 95% of the data, it's a straight line. Now, of course, you need to interpret it. One interpretation is because if you really look carefully, the straight line meets the black line only in few points. So one could argue, what are you talking about? I never see the black line really following that straight line. Well, it's an interpretation based on stats, right? That statistically, the general pattern, the general behavior of Bitcoin follow that straight line. It's actually a very precise, it's not hand waving, it's a very precise mathematical definition of what is the interpretation of that straight line. And you can see from an intuitive point of view exactly what you were saying. It's the data is oscillating back and forth. So in a sense, it cancels. It's almost like this bubble didn't exist. Only the general pattern exists. And when you find something like that, like I say, you can do what they say was crazy, is to write a single equation. Think about how absurd that is, right? You have an asset that existed for 15 years, millions of people interacted, they buy, sell it, it goes up and down, it crashes, but the general pattern can be described by a simple equation. What is that equation? That equation is here in the title. Price, P, equals some constant. The constant, by the way, is related to the y-intercept of that straight line, because to define a straight line, you need two numbers, the y-intercept and the slope. And then you get a unique straight line. The intercept gives us A, and then we can look at it, the significance of it in a moment. And then time, because time is what we have on the x-axis, right? P is what we have in y-axis, and time is what we have in the x-axis. I wrote it in this way, t minus t1, where t1 is the block, the genesis block, the origin of time. So the difference between whatever time you're considering and the genesis block. And then you take that to the alpha. So you take the power. This is why it's called the power law, because of that power. And the power is nothing else than the slope of this straight line. And that slope, it's 5.72. So a number close to 6. It's not amazing that we can do that, but it's actually, we can tell the general behavior of Bitcoin with one single equation. And that actually, to answer your question, and again, I can stop for a second to see if there is any questions, or if there is any doubt or any comment about this, any pushback or whatever. So please go ahead if you do.
Yes, thank you. So I just want to emphasize here the difference between a power law and an exponential, because as you pointed out, the general form of the power law is y equals a times x to the n, and n is some exponent, it's some quantity that is fixed. X is the independent variable, so in this case, it would be time, and then y would be the price of Bitcoin, whereas in an exponential relationship, x would be the exponent itself. And that's the difference between the two. Just for our viewers, this is not positing that Bitcoin's price follows an exponential relationship. Rather, it follows the y equals a times x to the n relationship. And just so that we have clarity on the specific formula that you posited, it's this: P equals A, which is a constant, times this difference, T minus T sub 1, which is the time today minus the time of the Genesis block, which is January 3rd, 2009. And then this exponent, alpha sub 1, is 5.7278. So it's actually even closer to 6 than to 5. And that's interesting as well. It would be interesting to hear how you arrived at that particular exponent and what real world behaviors or tendencies would give rise to it, because that's a high exponent.
It's very high exponent, and so that means very high growth. So I arrived to it by simply doing the regression, right? So you do the regression spits out two numbers. One is the y-intercept, because this is how you define, right? You want to find this best fitting line, you run the code. The code is all based on mathematical formula and the statistics behind it. Then it gives you a bunch of numbers. When you run it in, I usually use MATLAB. Most of these figures that you see are people that are familiar with MATLAB, they will recognize them. But you can use Python or whatever. But it gives you several numbers. One number is the slope, one number is the y-intercept, another number is this r square, the p. The p, in this case, p means how likely is that this is due by chance, and the p is like, I don't remember exactly, but 1 billion or something like that. It's an extremely small number. It's basically impossible that it's due by chance. And the r square, that I was surprised being so incredibly high, because I play with a lot of phenomena biology, for example, neuroscience. And if you get like 0.78, 0.75, it's you can publish a paper, and it's an amazing result. Like, whoa, this is incredible regularity, and usually you don't see that. In particular with social phenomena, you don't. I had the misfortune of reading some of these social papers that people put out, maybe because of some scandals, some that probably you heard about it, some plagiarism scandals. So I went and read these papers, and we had we had R squares that were ridiculous. Like a physicist will laugh about them and say, "How do you even publish anything with these silly R squares?" But this is almost a physics like R square. We are really used to very high R square because physics patterns are very regular, and this looks almost like that. This is why my entire thesis is that Bitcoin is more like a force of nature than an asset, that is something going on. So you ask some interesting questions. First of all, we will see in a moment, I will make a big deal of this N, because that N, notice, to be a power law, that N can be anything, right? So basically anything that has this shape is called a power law. It doesn't have to have a specific N. Every phenomena has its own N. Just to give you an example, with Kepler's, the planets move around the sun, right? And if you measure the distance of a planet, it's more complex because we have elliptical orbit, but let's simplify and say we have circular orbit, so let's call it a radius. So if you look at the distance of a planet from the sun, and then you're looking at the time that it takes the planet to go around, the orbit, basically the period of the orbit, that is a power law. And in fact, it goes as the distance equal or proportional, because there is always some kind of proportionality constant, basically this A, proportional to the time to the 2/3. And that 2/3, it's a fraction. So N doesn't have to be an integer, it can be a fraction, it can be 3.9, it can be any number, it can even be negative number. So anything that has this relationship where there is, in fact, this also even covers the simplest case where N is 1. In that case, it will be a linear relationship. So, even a linear relationship in a center sense is a very trivial, non-interesting, because really the interesting part is that if at N is not 1, then the relationship is non-linear. And non-linearity brings a lot of interesting behavior in the system. This is like one of the things that modern physics is very interesting to study. This non-linear, we also call them complex systems, when they have a lot of non-linearity. And 6, as you notice, is very high. So it's a very, very non-linear system. And also it means that Bitcoin is going fast, very quickly. If you want to look at how it looks like in a linear graph, it looks like this. So what I did here, I average the price with a moving average over 4 years. And why 4 years? Because these bubbles that we can discuss in a moment happen every 4 years, mostly because of this very typical Bitcoin event that is called the halving. And so they tend, these bubbles, these big peaks that you see in the price, they seem to happen every 4 years. If you average over 4 years, then they kind of get smoothed out. And you can see that is the black line. That looks much more regular now. And the red curve is the power law. Because basically it's like, if you think about it, it's kind of like a parabola, but a very fast moving parabola, right? Parabola is another power law, because in that case we have square, and this power law, it's 6. So it's much, much faster. So when people say, Bitcoin goes up and down, what are you talking about? Bitcoin goes up and up and up. That is the real general behavior of Bitcoin, is moving up like that, like almost like a hockey stick. That is how it looks like in a linear graph. You go back to the linear graph. But so this N is almost like a fingerprint for the phenomena. So you mentioned different phenomena. So I mentioned Kepler's law. There is another famous, in fact, we can spend a little bit time to discuss it. I have some graph about that. There is a physiological phenomena where the metabolism of an animal, how much energy an animal consumes, is related to the size of the animal. And that relationship says that how many watts the animal consume in energy is proportional. Again, there is always some proportionality constant to the mass of the animal, again, to the 2/3. To 3/4. I made a mistake. 3/4. And that 3/4, it's really cool because if you go deep, and for example, if you read the book Scale, there is an entire chapter dedicated to that because it's kind of a crazy rabbit hole. It talks about fractals property of a human body, that this where that 4 comes from, because we kind of almost like are a fractal beings. We live on 1 foot in the 3rd dimension and 1 foot in the 4th dimension, as humans. And it turns out that it comes out from the physiology, this number. It's kind of a hint about that. And there are, like, for example, that if you guys have some kind of a bright light, or maybe I'm looking at outside, I see the sun, the luminosity of the sun is, or any star or anything that emits light because it has a temperature, right? Because it's hot. We are familiar with that, right? You look at a piece of metal that is taken out from very high furnace, of a high temperature furnace. It looks kind of whitish blue initially, and then as it cools down, it starts to go yellow, and then orange, and then red, right? And then no light at all. It still emits light, but it's infrared light. So the temperature, the luminosity of the object goes with the temperature to the 4th. And again, it's a power law. There are power laws everywhere, almost all around us. I don't say everything is a power law, but a lot of things are. And so one of the goals in researching Bitcoin will be what that N is, where it comes from, right? And I had many sleepless nights trying to find out why 6, where the 6 come from, what is the significance of that 6? Because if I get my hands on that 6 and where it comes from, I did, in a certain sense, and I know it sounds crazy, and it's an alpha joke, alpha true, but Kepler discovered the Kepler's law, right? And he showed it in that way. And it took almost 100 years for Newton to come by and say, oh, I know where that 2/3 comes from. It comes from this law of gravity. By the way, gravity is also a power law because basically it's 1/r squared. So you can write it as r to the -2. So it's also power law. And there is this other power law that is more fundamental. So in a sense, he was able to explain a higher level power law with a more fundamental power law. It is a lot of what we do in physics, by the way. But there is this fundamental law called the law of gravity. And if the planets are going around the sun and they have this distance, it was able to explain this relationship that Kepler's observed through the laws of gravity. And it took almost 100 years. But if I am able to explain that N, I'm basically doing both what Kepler did, because he was discovering empirically the relationship, but also explain the reason, the cause of it. It sounds so silly because you go and tell, oh, there is another power law that explains this power law. So it looks like all power law all the way down, that is silly. But, hopefully by the time you go down, you learn something. You go a little bit deeper in the causative chain, right? That is the goal. And maybe one day we go to the bottom and we found out where everything comes from. But that is the goal. Now, let's look at this formula a little bit closer. So if you think it's silly, I invite everybody, and there are different calculators online, etc., and you can do that. Go and look at different times in the history of Bitcoin. So first of all, we can do this together so we can also understand the significance of this 10 to the -17. Notice is an extremely low number. Genati, sorry because you are such a clever guy. So I'm going to ask you this question, not putting you on the spot and trying to make it more interactive. Do you have a guess why it's so small, that number? Or anybody else? I know Genadi in person, so this is why I'm involved. I'm trying to be like the professor, and I'm asking Genadi.
Yes. 10
yes.
to the negative 17 days. Yeah, that's an interesting selection of units. I'm thinking it may be because you
Well,
started.
let me interrupt you in a moment. The unit, I not putting there the unit because you're right that quantity needs to have a right unit, right? Because, and that is one of the things that sometimes I hear people pushing back, but it's mostly a misunderstanding. I'm not putting them here not to make people more confused than usually are. And so what really this quantity has as units is, if I write it down here, dollars over days. Oh, okay, I can rewrite it. Days to the 5.7 to whatever it was, the number. Let's okay. Was that the number? I don't remember. It's a number close to that, right? Days. Okay, 5.83. I say 5.83. Let me rewrite it. Maybe I change the font. Okay. So here, same. So basically, what happens with the unit that this quantity 10 to the minus 17 has are such where the units here, because this should be days, right? So also these days are number of days times days, right? So number of days times days, right? This is why you see why I don't write all these, because otherwise we look like messy. And so I try to simplify. But basically, I'm trying to tell you that the units will cancel out, where you are left with dollars, because it should be a price. So whatever number you get, you should get the dollars. So I'm going to erase again all these because otherwise it looks messy. But forget about the units for now. Just asking in general why that number is so small. What could be the reason? In fact, one way. Yeah, go ahead.
So historically, the range of Bitcoin prices has really been huge. If you consider, say, the Bitcoin pizza transaction, where I think 2 pizzas were exchanged for 10,000 Bitcoins, as compared to today, when Bitcoin might be, say, around $60,000 per Bitcoin. So that range is just immense. And also, if you take a number of days to the power of 5.83, when the days start getting into the thousands, and you take a number in the thousands to the 5.83 power, that's going to be huge as well. So I just took 3,000 to the 5.83 power, and I'm getting a number 2.43 times 10 to the 17th. So that's the scale that we're dealing with already in terms of the Bitcoin prices.
Yeah, could I get hazard a guess here? Does this have to do with, could this be related to the CPU cycle time to complete a block hash to mint a Bitcoin?
It's something that I need to think about, but it's actually, the answer is so much simpler. Let's look at, to give us an intuition, let's look at, in fact, Gennady, you're on the exact right track. And in fact, you almost hit it on the nail, but let's make it even more simple. Let's substitute days. Remember, this is for days here. I mean the number of days from the Genesis block, right? So let's look at what happened at day 0, for example. This is how you will do, if you want to have some intuition. Say, let's substitute. What do we get as the price of Bitcoin at day 0? Well, 0 to anything is 0. You multiply by a very small number, you get 0. So the price of Bitcoin, according to this model, at day 0, when Satoshi invented Bitcoin, was literally 0. So all these people who were saying Bitcoin will go to 0, they were right. It was already at 0 at day 0. Was nothing. Now let's go to day 1, right? Day 1 to anything, if you take a exponent, basically, because it's like saying, and let's round it up to 6 because it will be easier to understand, right? 1 times 1 times 1, 6 times. I multiply 1 because that is what it means to take an exponent of something. I multiply 1 by 6 times by itself. I get 1. 1 times 10 to the minus 17 is 10 to the minus 17. So 0 so basically that is 10 millionth of a billion, something like that. It's a really small number. So Bitcoin at day 1 was not 0, was very small number, almost 0, right? 0.00001 dollars. This is what it means. Now, it seems silly until you say basically kind of what you did and say what that number of days need to be before actually get some numbers that I can recognize. Like, for example, $1. How long did it take for that equation? How many days I need to actually get something on the order, like you say, if I take a number and then I take 5.83 and I get something close, and you got 3,000, right? That's the number that you use. What did you use?
I just took 3,000 to the 5th power to get a number that was on the same scale, like 2.43 times 10 to the 17th power. But yes, it would be in the thousands of days.
In the thousand of days. In fact, I can do it myself, and we can find out. And then I invite everybody with a calculator to try that. So let's try 1,000 days, right? If I take 1,000 days and they take 5.83, the power of 5.3, and everybody with a calculator can actually follow me along, I will get something like 3 times 10 to the 17, right? So this in this case is positive, right? This is what I get. And I can write it in the slide. So I can write it in the slide what I get. So if I do, if I take the power of days, in this case I choose 1,000 days, and I take days to the 5 point, and everybody can verify if this, because in Bitcoin we say do not trust, verify, and in science is exactly the same thing, right? And transhumanism is the same. We verify everything we say. We are dreamers, but we are planted in reality because reality is what counts. So if I take this, so if this is 1,000, and then I take the power of 5.83 of this number, I get 3 times 10 to the 17. So you can see what happens. The 10 to the 17 cancel the 10 to the minus 17, because the 10 to the minus 17 means 1 over 10 to the minus 7. So 1 over 10 to the 17 multiplied 10 to the 17, they cancel each other, and I'm left. So if I do this with the price will be, right, because I will have 10 to the minus 17 multiplied by 3 times 10 to the 17 equal 3. So after 1,000 days, the price was $3. And you guys can go and check in a chart what the price was. $1,000 days is about 3 years, right? Because you can take 1,000 and divide by 365, you get 2.7 years. So it took about 2.7 years for Bitcoin to reach parity with the dollar. And if you look at, I think if my memory is correct, it took about 950 days to reach parity for the, correct me, but around that number, very close to that number, for the historical Bitcoin to actually reach that parity. So that silly formula that you can laugh about, it does exactly that. When you try to play with it and try $10, try 100. Now, very big times when the number is quite off, because you see these crazy bubbles, right? You see this bubble, but by the way, I also try to model in my model, because I can modify my model where I include the bubbles too. Like you do it in physics. You start with a general pattern, and then you add modules. You say, okay, let me add I'm describing the fall of an object. At first, I don't consider air drag. Then I add air drag, I add wind, I add all the different components to make it more and more realistic. So I can add the bubbles because they are very periodic. It turns out they follow a very precise pattern. Also the bubbles, the size of the bubble decay in time, even that is regular. Almost everything in Bitcoin is like a clock. It's really weird system. Even just if you are not interested in investing in Bitcoin as a scientific system that represents human activity, it's really strange because not many other social systems behave in this way. And so you can try and substitute different numbers. Like, for example, right now, if you substitute, and you can always go online and say, we can try today, right? You can say, how many days, I usually use Google, how many days from January, in fact, it comes up immediately because I do this search all the time. So I just simply write in Google, how many days from January 3, 2009 today? And ChatGPT will also be able to answer this very quickly. So it's 5,740 days. So what if we substitute that in the formula? What do we get? So I'm going to use my calculator, 10 to the minus 17. I take multiply by this number, and I take the power of 5.83. What do I get? And again, everybody, Gennady, you seem to follow along. What do you get?
Yes, just a moment. I'm trying to validate the number of days between January 3rd, 2009 and today. So I found a website that does the number of days calculation, and that is...
I love that, by the way, Gennady, that you're trying to validate. I love it.
Thank you. So let's see. It's 5,748 days. So
correct.
Yes. And then we will take the base. So 5,748 days to the 5.83 power. And that we can multiply by 10 to the negative 17 power.
Yes.
Okay, that's 82,790 for me.
Perfect. Right. That is a little bit higher relatively to where Bitcoin is right now. But, remember, the interpretation is we are kind of calculating the fair value of Bitcoin, right? And that fair value can be higher or lower. Many times it's very close to the real number. And right now, for example, we are undervalued because the theory, we can go a little bit deeper, but the theory says, basically, if you look at this pattern here, right, it looks like if you study the behavior, it looks like it's very regular. We spend about 2 years along this lower level, and I can show you actually some relevant graph about that. So it looks like when you start to go deeper, because the beautiful thing of this approach is that once you start to find this mathematical pattern, now you can go deeper and trying to see if many things. Like, for example, we found this very interesting line. So this line is about 60% relatively to the trend in the middle. And so it acts almost like a support. Look at this blue dot. Look how incredibly crazy it is with this blue dot. By the way, I calculated this blue dot using this technique called ransack that basically it eliminates the outlier. So I draw in black the outliers and notice what they are, the bubbles, right? And then there are these dots where they basically Bitcoin in between the bubbles tend to happen after the halving, follow almost to a dot that power law. And notice what happened when we leave the power law. it takes about and I know because of this time distortion due to the nature of the graph, they look closer and closer and faster and faster. But imagine all of them are 4-year cycles, right? So we spend 2 years at the bottom, and then when we leave a power law, that by the way, we think that bottom, it's the real power law, it's the real phenomena, that probably we have a lot of hints, I don't want to go too much in the details because we did so much work. All the research that we put together, I write articles to explain, etc. But right now, and by the way, it's not just me. I have we have right now, kind of jokingly, a group called Bitcoin Brain Trust, and we have like a bi-weekly show where we discuss. But in that group, there is another astrophysicist. He has a Ph.D. from Harvard, and he has older gentleman. He has a very successful career in science. Then we have a Stanford mathematician, Ph.D. His name is Fred Krueger, that is very popular also in the Bitcoin space. And I showed him this graph and immediately recognized it and say, oh, wow, it's a power law. Because I knew that any person with a little bit of training will recognize immediately the pattern. And since then, he's like a power law fanatic. And then we have a professor in finance. We make a group. So many other people have verified these. They did all kinds of statistical tests for robustness, for cross-validation, etc. But this pattern is really amazing. And, this support line. And we think that is really a physical property because it has to do with the energy required to mine Bitcoin. So it's really because Bitcoin has that aspect of physicality, the energy that goes into the system to support it and make it work. And so it turns out, like if you use hash rate, for example, you make a model of a price based on hash rate, you come very, very close to that support line. And so we think it has to do with the cost of mining a Bitcoin. And you see, is rarely violated. Like you see that little drop. It was not little, it was enormous, but it looks little in the log graph. But around 4,250, very, very sharp. It looks almost like a V. Do you know what that is? Any guess? What could it be that sharp drop in price that went down very fast in relatively recent times?
In relatively recent times, could that be the FTX scandal that
it happened before that?
Could it be COVID?
COVID.
Yes.
It's COVID. And notice, and this is one of these things that people will call a black swan, right? Because it's a very big event, unpredictable event, etc., that disrupted the economy and the supply chain and so on. Look what happened. It arrived to that red line, it jumped, and it went back. That is exactly what you will expect from a system like this, because power laws, by the way, are associated with anti-fragility, are associated with adaptability, because basically they work on many different scales. We will discuss it in a moment. That is one of the main characteristics of power laws. They are scale invariant. And when you have something that can work and can deal with events at all scales, big, small and big, you will have something that is very robust, very resistant, anti-fragile. That is exactly what you want for a system like Bitcoin to be. And so it's one of the beautiful properties of this system that is associated with power laws. But so I was trying to tell you, you start to dig in and you're looking at all these interesting properties that having this particular look allow you to discover. And I was telling you the pattern that we found out also because I did different studies. I have hundreds of slides here. I'm just selecting just to show you some of the things I discovered. But basically, I started to study the periodicity of these bubbles and from what exactly a mathematician, a physicist will do. And I found things like this, right? So if you average all these patterns and you put them on top of each other, and then you look in how regular they are they matching? So these are, our scientists will do. Imagine this is like you see graph like this when people describe the motion of these extrasolar planets, because we are trying to get the data and we are looking for periodicity in the data. So you will put the cycles of the planet on top of each other to see. Many times you have a lot of noise, and by summing signal and noise, the noise cancel and the signal comes out. Same thing here. I'm extracting the signal of these bubbles. They are so strong that you can see with your eyes. But in this case, I was trying to see how regular they are. And you can see they are very regular, because even if you add the error bars, so these error bars show basically how much irregularities there are relatively to each other. It's much more regular here. That is when we are close to the bottom, to that support line. But then as you go to the bubble, it starts to be much more regular. In fact, the peak and the bottom are the place where there are less uncertainty. They seem to be very, very precise where they align. And so, in fact, you can use these to predict when the next top will be. That in our case is going to be November 25. And we can even tell, because one of the things that we observe is that actually the bubbles decrease in time. And I was very surprised to find out. Now, you have to be careful, because while with the power law we have thousands of points, the bubble themselves are only, if you exclude the first one that didn't happen after the halving, so you take only the 3 associated with the halving, the decay of these bubbles are an exponential, and very, very precise exponential. In fact, if you include the first one, if you want, even that actually follow an exponential with the other one. It's so weird. I don't know, because you will think that these bubbles are due to FOMO or whatever, and they are not. Yeah, maybe they decrease over time because the system is bigger and bigger, so it's more difficult to move billions or trillions of dollars and a few $100,000 or millions of dollars. But why they follow a very precise pattern where you could have used the first 3 bubbles to actually predict the last bubble in the last cycle within a few $1,000s. It's crazy. So this is what also we do. We use that with a grain of salt, because that is the weakest part of this speculation, of this analysis that we are doing. We can kind of estimate the size of the next bubble. We think is going to go all the way to 200,000, and then it's going to crash all the way to 75,000. And basically, if you want to describe a dynamic of a cycle, it takes 1 year to climb. And it's interesting because I also show that actually it's an exponential. So the only time when Bitcoin is an exponential is during the bubble. We go up exponentially, we reach a peak, then we go down exponentially for another year. It's like clockwork. I don't know if you guys are interested in Bitcoin in general and you ever realize this is exactly like that. It's very, very regular. 1 year up, 1 year down. It takes 2 years to stay in the bottom, and then the cycle repeats. And so far, we have done these 3 times, and we are seeing if it's going to happen a 4th time in this, because the cycle, right now, we are coming close to November, and November should be here, where the new cycle, the new bubble starts. And so in November, the new bubble should start. We should go up, reach 200,000, go down to 75. This is the next cycle. And, I studied this mathematically, what is the likelihood, and, I try to do everything in a very scientific fashion, because differently from other assets, Bitcoin works like that. And so do you have any questions about these things that I just introduced?
Yes, I actually have a variety of questions that I think it would be good to explore. First, Daniel has a question, so I will let him precede me, but then I will ask my questions as well.
Yeah, I'm sorry for the people that don't have the visual benefit, because this is a great series of charts. But early on, you had a chart that had a blue line that said this blue line represents the collected data we have. I'm wondering why that blue line of
this one.
No, it was earlier. I think it was like maybe 7 or 6 on your PowerPoint deck. I think that's not back a little. Oh yeah, that's the one. Number 9, I think, or number 6. Number 6. Yeah. Okay. See the blue line up in the upper right hand corner. You said this represents our data set, right? So why doesn't the data set go all the way back to the Genesis
No.
block?
So we, okay, two separate questions. So why doesn't go all the way to the Genesis block here? In fact, it starts at about 2010, right? If you go and substitute, because we have graphs with dates, I think this one. So you see it goes all the way to August 2010, right? Why don't we have a first year of data? Mostly because this is when the first exchanges opened. So this is when Mt. Gox opened, which was the first historical exchange. And then, we usually take all the other exchange, we average them, but at that time you had only one exchange, and this is when it started. So when the exchange started to open, we had minute data, second data. We had a very, very regular data that are stored somewhere. You can access them, you can study. Before this, there were USD and other currency exchanges. The first one, I think it happened sometime in middle 2009. I don't remember, but it was one historical transaction. Mostly people will go online. There were chat groups, where people will say, "Hey guys, I want to sell some of my Bitcoin," because you could mine Bitcoin using your laptop. At that time you didn't need all these specialized machines that people use right now. And some people were selling them. Probably you heard about the pizza event where two people, this was the real first shopping with Bitcoin. Somebody bought something physical with Bitcoin. And I think it went like this, where somebody in England was talking with this guy in Jacksonville, Florida. And this guy in Jacksonville, Florida wanted pizza. He had two pizzas. And the other guy used his card, called the pizza place, bought pizza, and then sent, the guy in Florida sent 10,000 Bitcoins or something like that. That pizza is the most expensive. You could have bought, a chain of pizza places in that case. We get the money right now, right? So this is how many people did it. And, some of them are recorded, we know the date and so on, but most of them were just between peers, so we don't have a track of that. I did add, I don't know if I have it in these slides, but I did add like little stars backwards. And actually the power law goes through them. For example, the first historical transaction where $1 was 5,000 Bitcoin. Can you imagine? That was in 2009. And that one sits on the power law. If you go, I didn't include it in my model because I started to include I use the Genesis block as my origin, but I didn't include that data in my data set. But if I go backwards, almost like you do, kind of forward testing, but in the past, it goes through that. It doesn't go through the pizza. So the pizza is actually much lower. It was a bad deal, even with the value of Bitcoin at that time, according to the power law. The guy didn't get a good deal at all. He could have bought many more pizzas if he tried to sell it at a fair value of Bitcoin. But
I would just point out that day is still celebrated every May 22nd.
Yeah.
Have parties, they give away free pizzas. It's like a worldwide free pizza.
Exactly. Because, even if it is crazy that somebody traded Bitcoin for such a low amount of dollars, we celebrate because it was like a demonstration that actually you could use Bitcoin as a mean of exchange, right? And many people didn't know that or didn't. So it was a demonstration of that, a use case where people demonstrated that actually could be done. And there were Lindell dollars, people were exchanging for Bitcoin for Lindell dollars, because many Bitcoiners, like many transhumanists, are libertarians, right? So we were trying to get out of the system, out of the printing of the dollars and inflations and all kinds of things like that, right? We want something, a money that is not controlled by government, that is not controlled by state entities and stuff like that. Now, that explains why we don't have data before 2009. Does it make sense? But in our fitting, we always use well, not in our fitting, indirectly we use the Genesis block as our starting point, because time is always denoted in terms of days from the Genesis block. But we started the fitting here. Now, that blue line that you were asking about is what I was showing basically. So of course, I include all the data, but I was trying to say, if you think that, we need to wait future data to show if a power law is right, you are incorrect, because I have discovered this power law in time. I discovered the other one in 2013, but this particular one between price and time, I discovered it in 2018. So I was just marking where the 2018 event was. That is basically when I discovered the power law up to now. So basically all this, it's already success by the power law. We already predicted all this time, this event. Because again, you say, well, which kind of prediction is that? Well, as a general trend, and you will agree, I was right? I have been right for 6 years in telling you in which direction, because it's important, right? If we went exponential, we will go very far away from that straight line. If we collapse, we will go very far away. So the general trend, this is what the power law is trying to do. It did a very good job in predicting that, right? You will agree. So that what that blue line tries to tell. Does this answer your question?
Yeah, I misunderstood. I didn't realize that start of the blue line is when you started to fit the data to the power law, and you validated that it fits. But yeah, you have
correct. It does a good job in predicting the past, but it did also a good job in predicting the future, because basically I started to predict the future from the beginning of that blue line. Yeah.
So you say, there's a old rule about currency that it has to be stable and fungible and non-volatile. And if it wouldn't seem volatile, people looked at it with the right scaling factor, right?
Exactly. If that is the key, right? Using the right scale. And then when you look at it in that way, from a scale point of view, then it looks regular. And by the way, given that you mentioned scale, so two things, because I know that we're running out of time. I want to mention two fundamental things, and then we can maybe discuss, or maybe three. Allow me to mention three fundamental things. And I will do it very quickly, and then maybe we can discuss. Do we have a hard time, Gennady, or we can go a little bit longer, or what?
So the hard time will be about 22 minutes from now.
Okay. So the first one, I wanted to put Bitcoin in the context I already mentioned. There are all these beautiful power laws everywhere around us, right? So, for example, the planets, look at this. Beautiful. And these, I would recognize them. You look, you do log plot, log of a y-axis, log of the x-axis. If you see a straight line, it's a power law. You measure the slope, that gives you the fingerprint. That gives you some hints of what is going on about that particular law, about that particular pattern. That is the cause of this behavior that we observe. And there is this beautiful relationship here. So we go from the physical world. There are a long list here, for example, a list of all the physical laws that are also called scaling laws. And we will discuss in a moment why scaling and power law are basically synonymous. Scaling laws, power laws, right? I don't call them all the time scaling law, because there is also this issue of scaling Bitcoin in terms of on many transactions there are, and people could get confused. But you see, look at this, a long list of physical laws, and I don't think it's even complete, that are all power laws. And you see here the exponents, 1, 3, 5, 4, -1, many different ones. And all of them, if you understand this exponent, then you understand something deep about what is causing, or the nature of that particular law. I love this one that I mentioned before. We can maybe spend a couple of minutes on this one. Basically, is a relationship where it tells us that there is this so this is one of the things that as physicists drives us nuts, because in a good sense, because we love it, when we see universality, when we see that there is very regular behavior among many, many different things, because you will think these animals don't have much with each other, right? There are birds, like here we have small birds, there is the mouse, wild birds, goose. These are flying. These are, some of them are, predators. Some of them are herbivores. You will think we have very, very different lifestyles and different size. And you will imagine, yeah, maybe there is a rough proportionality between how much energy they need and how big they are, but not something crazily regular like this. What the heck is going on there? And this is what, as physicists, make us happy. And many biologists don't care for some reason, right? And now biology is becoming more mathematical, more physical, but in the beginning it was very, very qualitative. They didn't think that there were many irregularities like that. And when physicists started to enter the field, we started to find all these irregularities. And Jeffrey West actually has some interviews where they say they even gave him hard time. Like he mentioned, one time it was time to publish a paper where he found some other power laws or whatever, and they gave him 7 referees. And I don't know if you ever publish a scientific paper, it's usually 3 at most, right? This is what you get. The fact they gave him 7 referees was, okay, we will try to do everything possible to find somebody that doesn't agree with you, so you don't publish it, And finally published, because, it doesn't matter how much resistance he got. He was right. The math was math and the data was the data. And the field is changing, but he was telling this thing. And it's kind of funny because I found a lot of these resistance with Bitcoiners. When I show my data, they tell me, some people appreciate, some people like it, other people insult me and they make fun of me or whatever. It's not always easy because I love, the reason I do that, because I love a social aspect, notwithstanding the challenges. I love a social aspect of being a Bitcoiner, and I want to share my finding with the community, and I'm going through that. And many times I learn from them because, they have very good questions, comments, or challenge and make me think. And so it's a very good back and forth relationship, even if sometimes it's frustrating. One of the criticisms of biology, right? Let me tell you a little bit about this. Let's see if I can summarize it. What this equation shows, beside orderly, and by the way, look at that, how interesting it is that a human consume about 100 watts, right? We are like a bulb. We are a little bulb of light, right? That is how much energy a bulb consumes, and and very efficient computer, if you think about it, right? Just on 100 watts, because mostly of that energy goes to the brain, right? I think 50% or something like that. Notice that the woman is a little bit lower. So you can learn a lot of things, like why, for example, the birds, like these small birds, are higher relatively to that line, because they fly. So they use more energy given their mass, right? So you can learn a lot of things about animals by looking at this, how everything is organized in this graph. But the general pattern, the slope, is 3/4. So what does it mean? It means, and you can do it in your calculator too, because it's nice to verify these things. So if you take the power, so imagine I'm doubling the size of an animal, right? So you will think, this joke of a spherical cow, physicists say, let's think about a cow, and okay, it's a spherical cow, because we try to simplify the shape and we say it's a sphere, right? But it's approximation that is a sphere. But imagine I'm doubling my animal, right? I'm kind of doubling the number of cells. So you will think, if a cell have a certain rate of consumption of energy, you double the size, you will get 2 times the energy, right? So you will think it's a simple linear relationship between the mass and how much energy you're using. And instead, it's 3/4. So what is the consequence of that? So let's say I double the size of an animal, then I get 2, and I take the power of 3/4, I get, because I double the animal, so I'm going to raise the power, right, the change in mass to the 3/4, that is the exponent of that power law, I get 1.68, so about 1.7. So I get a discount of 30%. So when I make an animal bigger by a factor of 2, that is actually an evolutionary advantage, it will not be a big advantage if you had to use 2 times the energy, because at a certain point, you will need so much food that you will not be able to exist. Because let's go to an elephant. The elephant is about 10,000 times bigger in mass, because if you look at this, right, the elephant is 10,000, actually 100,000, right, because the mouse is less than 0.1 kilos, the elephant is close to 10,000, so we are talking about 100,000, right? So if you go up 100,000, and I'm going to do it in my calculator, and they do 3/4, I get 5,000. So it's an enormous discount by the time you go to an elephant. That 3/4 makes things where it's almost like an economy of scale. It really pays off for an animal to be bigger, because you get all these advantages. You don't get predators and so on, but you don't have to use all that much of an energy. Yes, a little bit more, but not 100,000 times, because if you add 100,000 times, we will not have elephants around, and will be a really huge pity, because I love them, right? Big ears and the trunk, and what a pity will be if a world didn't have elephants, right? So they exist because this economy of scale, how nature organizes. Now, if we want to go in the details of what happened, and the book Scale does an amazing job of that, has to do with our circulatory system, how basically the energy gets distributed, the fuel gets distributed in the body, where the body finds optimal ways of doing this. Bigger it is, better it can do this job of distributing the energy. And so it's very, very powerful idea. People have dedicated entire careers. There are hundreds of papers on this topic. It's called allometry, this idea that we're scaling behavior in sizing animal. And now I want to talk about a scale idea because it's so fundamental in trying to understand what is behind this phenomena. So you see, look at this. We say, and Daniel pointed out, right? If you look at the right way, this phenomena, and the right way is what? Forget about the linear changes. Look at how the scale changes. These changes is of 10, 100,000, etc. So if you focus on that, and then you see this linear relationship. And linear relationship means something that is consistent. It's one of the most consistent change that you can imagine, right? You change one quantity, the other change proportionally. But here, what changes proportionally? The scale. And this behavior, where the change in scale is consistent, when the scale is small, when the scale is medium, you can even imagine in your head animals. We made, by the way, I have a YouTube channel where we make these high production videos, and we made with my son this video where we make an analogy with the Bitcoin and different size animals, because it's actually a good picture, it's a good analogy. And so you think, you go from a mouse, we go to a cat, and then a lion and an elephant, and you're increasing the size. We are talking about many order of magnitude. Right now we go from 0.1, even smaller. In fact, actually, you know what? You can extend these, people have done it, to even unicellular organisms. They also follow this proportionality pattern, very similar, same kind of slope, all the way to cells. It's crazy. And so we are talking many, many order of magnitude, and it behaves in a regular fashion. So we call this behavior scale invariant, because something is not changing, but is how the system changes in terms of scale. It's consistent, it's gradual, it's a straight line. So this is a very powerful thing, because in terms of Bitcoin, for example, it means that there are all kinds of things happening in Bitcoin, right? There are individual buying Bitcoin, there are institution buying, small banks that are buying Bitcoin or trading Bitcoin or adopting Bitcoin. There are huge, big institutions, all acting in this system, almost like an ecosystem. Everybody's contributing in different way, and the behavior is consistent at all the scales. And this is the secret. This is what makes it basically a philosophy, because now you can start to say why this happened, why this system that is supposed to be the monetary system of the world that follows this very interesting pattern, that is kind of an optimization pattern, a least resistant pattern, that, this thing that is supposed to represent human value, because, people join the network because they want to escape the matrix, they have all these there is something behind Bitcoin that is not just speculation and wanting to make a bunch of money. That is part of it. There is much more, because talk with Bitcoiners, in a sense, is almost like a religion, or maybe a movement, like, transhumanism, right? We are here now because we are really excited about this idea. We want to change the world. It's more like a social movement, and so you can actually see, because that is the other resistance that I get from people is, well, okay, it works with planets, it works with animals, but it doesn't work with people, because people, free will, we can do whatever we want. Well, for sure, people cannot be described by math, but it's not correct, because this entire book here, actually, this is what Jeffrey West did as a career. He started to go from physical system. He was actually a particle physicist. He started to study biology, and then finally moved to social system. There are actually branch of physics called sociophysics and econophysics, where we actually started to study human systems, because we are also part of reality. We are also physical system. Societies actually they behave almost like particles. The people interacting. You can describe it in that way. And you see, this book talks about the growth of cities, economies, and many of these things do behave like power law. Like, for example, city. You see, in this case, is basically, you are familiar with what is called the Zipf's law. Basically, it also applies to languages. Like, if you look at the frequency of a word in a language, or many times a word is repeated in a language, and then you sort them in terms of how many times this word is repeated, it forms a very regular pattern that is called the Zipf's law. That is a power law, because it has that relationship, right? The frequency of a word relatively to the rank, in this case, the ranking of a word in terms of first, second, and third, so on. And notice this, how universal these things is. Even ancient languages, like dead language, like Latin or ancient Greek or Esperanto, all of them follow similar power laws. That is amazing, right? Because you will think something like human language doesn't have a pattern, etc. Instead, it does. And then cities, if you can do the same thing in cities, where you organize and sort them in terms of their size, and there are different regions in different countries, and you see these patterns, like large city, small city, they all follow this pattern that is power laws. And in fact, if you read the book, but also listen some of West talks, it says that even gas stations in a city are power laws. The number of gas stations proportional to the size of a city in a power law. The number of patents in a city are a power law. The GDP of a city is a power law. How fast somebody walk in a city is a power law. Somebody one time challenged me and say, well, okay, history for sure doesn't follow power law. It took me literally 5 minutes to go to Google, and I found the time in between conflict is a power law. And what more historical than wars can be? And I'm sure there are many other things, like other events that follow a power law distribution. So we are everywhere around us, and this is one of the things that I wanted to emphasize. The other thing I want to emphasize, because I think it's critical, and maybe we can stop here, is I did find the origin of that 6, where that comes from. Well, it turns out there are not one power law, there are 6 of them. So basically, all the different on-chain parameters, like addresses, hash rate, etc., they are all power laws. So do you remember when I was telling you, I was trying to describe how the adoption of Bitcoin, because addresses can be understood as a proxy, right? Because more addresses there are, more people probably are creating these addresses. So it's a proxy, unfortunately, but also fortunate, because we don't have to write down our name when we buy Bitcoin. It's a proxy of the activity in the network. So if you understand Bitcoin as a network, then a lot of things get revealed. And if you're looking at addresses, it turns out it's a power law with cube. And by the way, it turns out that in certain condition, viruses spread like power law. And in fact, there are many historical cases, like AIDS, for example, that I know is not a good analogy, but think about a virus of the mind. AIDS spread with the cube of time. It is really interesting. And so addresses, it's a power law. It turns out this was one of the first power law I discovered, the relationship between price and addresses, that follows what is called the Metcalfe law. The Metcalfe law says, and here I have a diagram, that if you have a network, the value of a network, the utility of a network is not in the nodes itself, right? But is basically what you can do with the network. What you can do, you can connect all the nodes and do all kinds of things. You can transfer information. People can connect to a printer. All the usefulness of a network like the internet is not in how many people are in the network, but how many connections you can have between them. And if you extrapolate the number of, if you go to a large numbers, it's a bit relatively, it's not, a straight equation, but if you go to relatively large number, you get a relatively simple solution that the number of connections, it's proportional to the square. So basically it becomes like a power law. And look at what happens. In our case, we get a number, a relationship between price and addresses that is very close to 2. Now, what happened when you combine these two numbers, because basically it will be price equal addresses square, let's round it up, price equal addresses square, so the number of connections, but that addresses square grows with the cube, so you have cube to the square, you get 6, because when you're taking the power of a power, you basically multiply the power. So 3 times 2, you get 6. And this is why you see this beautiful power law in time. And then it turns out also hash rate is a power law. So basically it turns out it's some kind of a feedback loop where I didn't create this loop, some other Bitcoiner did, but many Bitcoiners have very strong intuition about Bitcoin. And then it turns out that basically my discovery shows that there is some math and some data to support that intuition. In this case, basically this cycle that goes through, Bitcoin creates a demand of a store of value that is increasing in time. And that is the emphasis. And by the way, guys, you got me in trouble because given my transhumanist vision, I want to emphasize abundance. I want to emphasize positive things about the future. Many Bitcoiners are doomer. Unfortunately, there is a section of doomers. And I'm fighting with these doomers all the time because they believe that the value of Bitcoin, it's in the scarcity. And I'm trying to tell them as a transhumanist, no, it's in value. The value is increasing. People want to join the network, and that is what drives the price. And people attack me because they are attached to this idea of scarcity. It's a different thing with the fixed cap. The fixed cap is good because it avoids dilution of the asset, but it's different from scarcity. And it's a very philosophical, deep issue. Maybe another day we can discuss it. We can discuss more of the philosophy.
Giovanni, we are coming up, unfortunately, against our hard constraint, but I'm thinking we need to do part 2 of this because there's so much more to explore in terms of your research about the power law. And there are many questions that I have and many questions that our audience would have. So I think we should schedule a second session soon to really take a deep dive into those questions, even fundamentally, why is it Bitcoin, or what would happen if everybody agreed with you that this power law exists and started kind of taking advantage of it. But I think this is fascinating, and it's fascinating that you have delved into this kind of depth and found parallels between the price of Bitcoin and other phenomena in biology and society, in physics. So I think it's well worth exploring. Our audience has been fascinated by this as well. So I really appreciate you joining us today. We've got maybe 30 seconds left if you would like to offer a closing remark, a final thought that you would leave our audience with.
Sure. So, it's, I think Bitcoin, it's much more than most people think, and it's very strongly related to a lot of things that are interesting to us. So I invite everybody, one of the things I told my audience was that I was going to orange pill you. I don't know. I'm sure that many of you have Bitcoin, so they got Bitcoin maybe actually early on. But if somebody didn't, please try to explore it with this different angle and try to understand it, because it's not too late. And by the way, yes, it will help you in the long term, because when we come back next time, I will show you where Bitcoin is going. It's going to $1 million, and it's all the fact that it's following a power law and is a scaling behavior. Almost, I don't say assure, because it will be a crime to say that. It's still an investment. There's still risk associated with it, but it's very likely that we go to $1 million. And if you're thinking with the right lenses, like Daniel was saying, we are talking about only 2 orders of magnitude, right? Because in fact, actually 1 order of magnitude to go to $1 million, because we are almost 100, and 10 millions is only 2 orders away. So it's quite easy for a system that went through 8 orders of magnitude to go another order of magnitude, right? 1 million. So we are 60,000. There is still a lot there, So
yes. And that is what
yeah.
we will explore next. But in the meantime, thank you so much, Giovanni, for joining us.
My pleasure.
And I hope that we can all live long and prosper.